Excited to be moderating this, bringing this to you. This event has kind of, I think, been a long time in the making, considering we're at sort of a crossroads here in strategy research and research in general as we think about methodologies that we can use moving from some of these predictive machine learning models that have been used in the recent couple years to now more generative types of AI. And so we have three great panelists. We're going to start with Stephen. Stephen's going to give us a little bit of a breakdown of the differences between predictive models and the generative capabilities that we're seeing come out. And then Bart will discuss some of his work on both ends and leaning a little bit into the generative AI and possible opportunities that we see there. And we'll wrap it up with Raj, who has graciously offered to help us with some insights also as a researcher and scholar and reviewer, but also from the AE lens and what he's seeing as an AE and these types of methodologies and how we can be building more robust research based on them. So as Lauren mentioned, if you have questions throughout the presentations, we'll do our best to respond to a couple of those at the end of each presenter. I'll just pull out one or two questions from the chat for Stephen and Bart and Raj to address directly. But if your question is not answered either in the chat or at the end of their presentation, feel free to bring those into the breakout rooms. The breakout rooms will be an opportunity for kind of a more informal discussion, and I'll give some more instructions on that format as we get into the breakout rooms. But without further ado, I'll turn it over to Stephen to kick us off.
Thanks, Joseph. Yeah, I'm really excited to be here today. So thank you guys for having me. My presentation is on human AI partnerships in research methods. So I want to start there and start talking about kind of the partnership problem is what I describe it as, right? This is, if I was to summarize what largely my work is looking at how do you design the human AI partnership so that it can take what is great about what we do as well as what's great about what AI does and able to bring them together. There's countless examples that we could find in the media where that partnership falls apart, from like lawyers using fake citations and so forth, right? There's a lot of examples. So how do we effectively design our partnerships with AI so that we can get all the benefits of our research as well as maintain that human benefits as well? But to really start that off, we have to have a good understanding of what actually generative AI is, and even more broadly, what artificial intelligence is. So I thought I would start there. So artificial intelligence is largely is when a machine is emulating human behavior. You give it a goal, so like identify dogs versus cats, and then it learns through experience as it sees a bunch of dogs and cats and fails and gets better over time and figures, oh, I get much better. And throughout time, we've seen that this technology has continued to innovate and improve till now we're at the generative AI stage, which is a whole fundamentally changed, right? So before, I would say like this started in our field, or rather, when we started seeing a lot more machine learning in our field was really the mid teens as we started seeing that come into our field. And largely what you see in a lot of those studies was they required a lot of data, because in order for machine learning to work, you have to have a lot of data, right? As well as these data sources would have a really clear ground truth of saying, hey, let's say I'm building an algorithm to identify handwritten letters. It's really clear what those handwritten letters are, and we can have a huge percentage of them. And that would be the value function of saying, hey, find the right handwritten letter it is, determine what it is. Generative AI changed the game a little bit, because instead of doing that, it said, hey, I'm going to give you the entire corpus of human knowledge. I'm going to give you all of that. Then we're going to play a game where you predict the next word. I'm going to cover up a few of them and say, hey, what's the next word? And it got better and better and better at doing that. Along that way, there's a lot of emerging properties that came from that have really changed our entire discipline, right? So if we think about this fundamental change with traditional AI, it's a lot of pattern recognition, classification, prediction, data processing is largely what we're in. It's largely the use of machine learning in the traditional sense was far more about making predictions, far more about creating really effective algorithms to predict something in measurement. And now in the generative AI world, now we're getting into content creation, reasoning, conversation. It basically flipped that. So now it's creating all of these things and create these patterns. So what's this mean for like research broadly is that it impacts every aspect of our research. Before, it was just focusing on largely measurement aspects where we can use machine learning to measure about anything. But now we're in this world where it can touch on every single aspect of our research design, from synthesizing hypotheses to all the way to helping us as a writing partner. It's hitting every aspect of it. So we have to be thoughtful in how we bring in AI throughout that entire process. So I thought what I would do to really highlight how this changes in our methods is talk about a couple studies that I have. One study more of the traditional machine learning method, and then one that I'm working on now that I'll be presenting at SMS in October, to kind of demonstrate here's how this changes. Here how this new innovation has the potential to change a lot of what we do. So to start with, the traditional measure, the traditional machine learning approach, I'm going to use my deception paper, where the question was, can we develop a machine learning measure to detect whether or not a CEO is being deceptive? That was the goal, right? And really, this was optimal for machine learning for a few ways. One, deception detection has a lot of shoddy measures, a lot of bad measures. So it's not just generally the most accurate historically, and it's a really high stakes measure. So it matters whether or not we're accurate, right? If I'm slightly accurate and I'm guessing we're trying to predict someone's big five personality or any other psychological measurement you might see in upper echelons, the stakes is pretty low, right? If I say someone is extrovert and they're not, no one really cares. But if I call someone a liar and they're not, they really care. So the accuracy really, really matters. Additionally, we have a lot of data and we can get a very clear ground truth. I can take a conference call and I can say, hey, at the time of that conference call, that CEO committed fraud. I know he did because we can prove it afterwards. So therefore, that's a lie. So the ground truth is really, really clear. So it made it ideal for machine learning. But I think what's important to step back and even talk about one of the downsides when you're using machine learning compared to like a human is machine learning doesn't really care if something's true. What it cares about is, am I following what you asked me to do? Am I following your goal? So your goal is X, Y, and Z. I don't really care if the way I'm painting that is what you hope I do. So they call this the dog and wolf problem. So there's this study that they try to have an algorithm predict whether or not a picture was of a dog or was a wolf. And it got really, really high accuracy. And then they went in afterwards and they realized what the algorithm had done is it created a heuristic where every time it saw snow, it said, that's a wolf. And in doing so, it actually got a really high accuracy, even though that's not true. That's not what we were looking at, but it still met the goal. And so there's a similar problem anytime you're working with machine learning algorithms is it doesn't care whether or not something's true or not. It just cares, is it being successful in the goal you gave it as, which is classify these two different photos. So when I was working on this study, that was the big concern is like, okay, even though I have the ground truth of deceit, how can I be confident that it's capturing what I'm hoping it's capturing and not actually snow? So what I did is I went back to theory. And what we did is we looked through all the studies that have ever examined linguistics with deception and identified all the things that should matter theoretically. And that was the foundation of my machine learning measure, right? To decrease the odds that it would go off in some road that I didn't want it to go. I said, I only look at these words, only look at these classifications. And in doing so, we found we got an 85% accuracy in the end. In other studies, when we played with this before we focused only on the theory, the algorithm was not accurate. In fact, it did worse than just giving a regression of just those linguistic categories. It performed far worse. So what it showed me in working in that is that it's really important to have that really useful combo of a human and AI, where the human is providing the theory and saying, no, this is what's true is. And I don't want you to get away from it. Here's where the truth is. And then the AI can then take that pattern recognition and take it at scale and help us be able to identify when a CO is being deceptive or not across hundreds and thousands of conference calls. So that's that combo that results in a really powerful methodological benefit for us, where now we can basically replicate that process with any construct. That if, as long as I focus on creating the theory first and focus on what are the things that matter for that theoretically, I can be able to replicate this over and over and over again and create really accurate measures for anything I'm hoping for, as long as I have that partnership right. The other things that mattered a lot that we found from this is, one, establishing validity really, really matters, because your reviewers correctly will look at this and go, well, how do I know that's not snow? How do I know that you're actually measuring deception or whatever the construct is that you're looking for? So the bar for validity is pretty high when you use a method like this. So just know that going in. But at this time, we were very limited by the existing data, right? If I didn't have all these conference calls, if I didn't have a clear goal, clear ground truth of deceit, I could not have built this model, right? That was a limitation of this design. But what if I don't have the actual data, right? What if I don't have the data? Which gets into the new study that I'm working on now, which is can we build psychometric measures that are just as valid without any data at all, where I have generative AI help me create the actual data set that then I can use as a measure from then on, right? So this would all be presenting in October at MSS, SMS. And we're going to be looking at integrative complexity. Now, the results aren't completely done, so I'm not going to be able to like get into the details of it. So if you really have a lot of those questions, you're going to have to see me in October. But this is the reasons why integrative complexity is kind of ideal. One, we don't have a lot of data of it, right? It takes hand coding to measure this, takes tons of time, very costly. So if I was to do this only through the old school hand coding way, this would take me years to capture enough. Additionally, even coding by hand, there's a lot of human bias that becomes a problem when you're trying to code this by hand. In fact, best practices recommend not just one reviewers, but like a team essentially, just to decrease that human bias. So there's this like benefit of potentially having an AI do this instead of some of the human bias that could come in here. Additionally, there are a frequency approach measure to try to capture this integrative complexity. But the leaders in this field, or the people who've actually created this initially, Tetlock and Sutfeld, both have highlighted that this measure of frequency approach is questionable in its accuracy, especially at high levels of integrative complexity. So again, a whole nother reason why there's a need to create more of an automated measure of this, and the frequency approach isn't enough. So what have we learned thus far in building this process? And again, I can't get too much in the details of the approach, but I would say that the data thus far has been incredibly promising. One, the prompt, and also I'd say the prompt process. It's not just what I found. It wasn't just building one prompt, but this entire process that I've had to build to create this data set. As the more it was grounded in theory, the better, kind of like following that same approach that we saw in the deception measure, that when we build the synthetic data, the more it's grounded on what we know to be true, the better the results is. And additionally, we are using a multimodal validation process where it's not just a human who validates and checks to make sure if it works, which we do, but we also are testing it with after we generate it, we then test it against Claude, against Gemini, against ChatGPT as another way to kind of validate of, hey, you are capturing or measuring what you're claiming to measure. And so what I would say is like the big takeaways of this is that it changes what's possible. If we are able to create synthetic data or use synthetic data to create a new measurement, now we have the potential to measure anything. And yes, will the measures likely be some type of weak or not perfect? Absolutely. But once we can create a measure, then we can continue to improve on it and work on it, and get better and better and better, because that's the whole goal. It also decreases barriers to create measures. If I don't have to have access to a really expensive data source, yeah, I think that we're always trying to make our theories better. And so that's kind of what the nature of peer review is we get better. Okay, so here's what I wanted. So with that, I wanted to kind of make a transition. What if you're starting to get in this now and you're like, hey, I want to bring in AI into my work. How do I do that? What's like maybe I'm not experienced, but so what I thought was like, well, what I found is one way you can start bringing this into your work now is by bringing it into your classroom. Um, I've seen a lot of benefits within my AI human partnership within the classroom as well. The more I've been able to think about how to bring it in my classroom and bring it in teaching my students, I found that it's not only helped me understand how to use these tools in my own research, but I've also found it's helped my students as well, right? One of the questions that I have people think about is how long until it's required for our students to be competent in AI? Right? How long until it's expected that they have AI competency? Probably many of you are thinking, well, now, which is correct. Right now, jobs are already asking for people to have AI competency. Then I would even ask you, at what point is it required for PhD students to be competent in AI? Which again, I'd probably say now. Uh, Students need both, and we need both. We need to be able to have domain knowledge as well as AI literacy, and it's possible to build them at the same time through scaffolding AI integration in your classroom, which I'd highly recommend doing. I found that it's made my class better, and it's helped my students gain higher levels of AI literacy as well as knowledge. So this isn't just one day of my class. I use multiple models in my class when I teach. So I'll have them go into ChatGPT, do a game that will it's kind of a knowledge check game of whatever I'm teaching that day. So this was industry life cycle. I then had Gemini, then went to Gemini, did deep research on the firm's history. Then they had to put that together, created a timeline, then put that into Notebook LM to create a podcast and images, right? So all these things that you could use to further reinforce whatever concept you're teaching, as well as as well as teach students how to use these tools when they're good, when they're not, right? What I actually found is that students' tests and scores, not only they improved significantly, as well as the students liked it a lot, right? They recommended it for other professors. They felt like it was very helpful for their learning. Um, and then additionally, in looking at the relationship between domain expertise as well as AI literacy, we found a 0.8 correlation that you can do it at the same time through this approach. So if I was to give you a recommendation, if you wanted to bring this in, if you wanted to just try to experiment, I would say an easy way you can start exploring this in your own work is bringing it into the classroom, because a lot of the things that we teach are ideal for bringing in with generative AI, such as Porter's Five Forces framework or any frameworks that you use. You can easily incorporate that with a generative AI tutor to give to your students. Um, I would recommend starting small. The numbers of tools and AI things that are out there is pretty overwhelming. So I wouldn't go too far in the deep end, right? So start small. As you work on it, what you'll find is that some of these tools have strengths and weaknesses, become important when you are trying to build an effective partnership. And so it's important for you to understand that, and as well as maintain human oversight. And the final thing that I would say is that these AI tools are not a replacement for humans. You're still going to need your co-authors, because these AI tools do not replace them. In classrooms, group work, this AI doesn't replace that. You still need that. But regardless, I found, at least in my own work, bringing in the classroom has been a very useful process for not only helping build my students' knowledge and competency with not only what I'm teaching, but also with AI literacy. But it's also helped me see different ways in which I can incorporate it into my own work, into my own research, and has made me a better researcher. Um, So with that, I'm going to see what other questions you have or whatever I think it's a couple questions, right, Joseph? Or is it next person?
Yeah, so uh, Jonah or Jonas had some thoughts on ethics. I would just maybe respond to those as well. I was writing something in the chat, but I appreciate Stephen. Thanks so much for the presentation. I think this is really awesome. As a basis for understanding how should we be thinking about using Gen AI at the critical point of we're never we can't replace humans, right? And it doesn't the machine doesn't care about truth. So I think that's part of Jonas's question is the ethics of that. Um, so I think that might be somewhat tangential to this particular session. But if you have just maybe a takeaway thought on the ethics of moving forward and making sure, because this is something I've been thinking about too, um, providing it to our students and allowing them to use it. How can we help empower them to use it correctly? How can we empower them, and how do we empower ourselves as scholars to use the generative capabilities in ethical ways? What are your thoughts on that?
I think it's about showing when these tools break down and showing when they work well and modeling effective tool usage, right? Showing them, here's how you can use these effectively. I largely I think that humans by nature care about truth. I think humans by nature are critical. I think humans by nature are creative. We've been that way for 300,000 years. I don't think this thing's going to change that.
We're going to go ahead and move along. If there are other questions, please go ahead and put those in the chat, especially some of the other participants. And I think Stephen would be happy to continue to respond to those. Thanks so much, Stephen, for kicking us off. And we'll move along to Bart.
I had a follow-up question, but you mean to my presentation, right, Joseph?
Oh yeah, sure. If you have a follow-up question for Stephen, maybe we can do one more and then you can take your presentation.
Or maybe go to Allison because I don't want to take up too much time of the audience. So maybe Allison's questions.
Okay, sure. So
My,
Allison asked, do you know of any comparison tables with different types of limitations of each tool that we could share with students when training?
Oh man, I'm not aware of I don't know of one the problem with that, they change really quickly.
They
And so
do.
like anything that is outdated. So I don't I can tell you one thing, Gemini is greater, much better at what's it good? That's great memory, the best with memory. I find Claude is the best with abstract thinking and more of that like a lot of the theoretical work that we're doing is where it really shines. ChatGPT is just like a jack of all trades. It's not going to be the best at those categories or any one of those things, but it's going to be decent at everything.
It's
So
really
that
good at coding, though. I've
yeah,
found it.
very
You
good,
said Claude is really good at that too. I haven't used Claude as much for the coding, but
very good.
for writing code, ChatGPT is really good too. Thanks. I think very practical, useful question. Thank you, Allison. All right, go ahead, Bart.
Art, you are muted.
I'm going to try that again. Thanks. Yeah, so I was saying, Joseph, thanks very much for the invitation and the team for organizing. Stephen, thanks very much for kicking us off. It's a great foundation to understand better the different type of AIs and how generative AI can push us forward in the research trajectory. So what I'll do is I'll draw a little bit from the studies that I was involved with because simply I know those best. And for those studies, I try to really emphasize the methods because of the purpose of the webinar. But before we do it, I just want to build on the discussion that Stephen started in terms of the difference between machine learning, supervised learning, predictive analytics on the one hand, and generative AI on the other hand. So in strategy, let's say we're interested in understanding better strategic decisions, how they come about, and what their consequences are. Typically, these decisions are characterized by their importance and they involve uncertainty and are often irreversible. So what that means is that at some point, managers have to commit based on some prediction of what they think their actions, how they will play out. So prediction is very important. And in traditional machine learning, that paradigm is called supervised learning. And the methods have become incredibly good at that. So the typical setup is you have some data with some labels. So in Stephen's case, is it a wolf or a dog, or is it a deceit or not deceit? And then you throw an algorithm at it and it learns some mapping between inputs and outputs. And the more data you have, in general, the mapping tends to be better captured by the algorithm. And once you have that model, then you say, okay, can I find some new data for sort of a new wolf or a new dog that allows me to classify or predict in the terminology of machine learning what's on the image. So basically use one data sample to train the model, and then you apply it out of sample for the specific purpose of what you have in mind. Now, that supervised learning paradigm is great and has been incredibly powerful and has tons of applications. Now, if we're thinking about how can we apply to strategic decisions, there's at least two hurdles in place. One is if we define strategic decisions as those that are ambiguous, uncertain, and usually have incomplete information associated with it, it might be the case that we'd have insufficient data to train our algorithms for the purpose of strategic decisions. The second is we often teach and research decisions that are whose optimal actions are unique to the focal company. So even if you were to have some data and you say, okay, let me analyze all the diversification moves or all the M&As within the industry, the average move for the industry might not be the best one for your specific company. So the points, just to reiterate, we may not have the data for the training. Even if we have the data for training, then the generalization, or maybe not generalization, but the application to our unique case may fail. So, and this is not to say that supervised learning is not important. It's just that there's some tension between the strength of supervised learning and the application within strategic decisions. Now, what's very nice for us is that this generative AI comes along and it has some properties that I think make it more suitable for a direct consequence or direct study of strategic decisions. So just to recap, what happens with generative AI, you take massive amounts of data that are not necessarily related or limited to the task at hand. So you train these generative AI models. Large language models is a key component of that. Once you have that model, then you can apply it to new settings with limited data or even without additional data. So you can train it in a setting or context that is not necessarily exactly the same as where you're applying it. So in a way, what it's doing is sort of lifting sort of two constraints that were in place with supervised learning for the application to strategic decisions, whereas generative AI, the data that is available can go well beyond the scope of the new task. And what you see is this sort of these emergent abilities that Stephen also referred to, is that even if you just start with next word prediction, it turns out that there's all sort of additional capabilities that come along. So this is just sort of a general agenda setting that I think supervised learning was great for the field and for as a research method. But I think for strategic decisions and studying strategic decisions, generative AI has some properties which can be especially appealing to us as researchers. So let me just highlight two studies that I've been involved in. And the first is on, so it's in SMJ. The first is on the strategic decision there is selecting a business model for a startup. And the approach that we take is that we're going to look at crowds of models. So we're doing sort of a wisdom of model crowd approach, where the idea is even if individual models are far from perfect, maybe their combination is much more powerful. So let me focus on the methods and the specific approach that we took. So we're evaluating business models in two sub-studies. The first, we're using generated business models that are generated with ChatGPT. And what's nice about that is that we can completely control the content of the business model. So it's high on the internal validity, but perhaps not so much or less on external validity. Now, in the business model competition, what we're doing is relying on data from entrepreneurs who submitted their business model ideas to a competition. And as part of that competition, there were human judges that then ranked or scored those submitted business models. So that helps us understand two things, right? Do the findings generalize beyond the generated business models, but importantly also in sort of a real world setting. So the goal is to understand, like, how do these generative AI evaluators, how can they or how do they operate with these type of decisions? So in terms of generative AI, what we use is 7 large language models from some of the providers that you've just heard, like Anthropic, Google, Meta, and OpenAI. And then we sort of varied the prompting. So the idea is that if you're doing wisdom of crowds approach, you want to introduce some variation that people or LLMs take different perspectives, and then possibly when one is slightly off, the other can compensate for it. And we started off in the initial one with 60 business models, but you see that the evaluations is much higher, close to 38,000. And the reason is that we're doing pairwise evaluation. So we present 2 business models and say, which of these 2 do you think has a higher probability of succeeding? And we found that this, for an LLM, is easier to answer as a comparative question than saying, is this business model good or bad? Because then the benchmark is less clear. So as a comparison, we also do human experts. We rely on academics who have studied extensively business models and what makes some good or less good. We got 51 out of 100 participating, and necessarily because of time and cognitive load, we could only ask around 10 evaluations per respondent. So that already shows you one big difference between generative AI and human experts. Even if generative AI may not be as good in terms of capability and not getting tired, the difference is massive. And for them, we got around 500 evaluations. And then we also had a sample of non-human experts. So let me just focus first on what the generative AI what kind of traction we got there. So in the first instance, we were looking at, well, if I present 2 business models, A versus B, and ask which one is better, do I get the same response if I ask the question A versus B as B versus A? And unfortunately, oftentimes you don't get the same response. So depending on the order you ask, you may get a very different response, or you may get the opposite response. And you see the models listed here, GPT-4 all the way to Llama, and the extent to which they are consistent. So ideally, this should be 1. So no matter which order you ask, it always prefers the same business model. But oftentimes it's not. And one of the reasons is that for some models tend to prefer the last option, no matter which model you present, and some of them prefer the first option. But then what we do is we say, okay, even if the single evaluations or pairwise evaluations are not that good from a decision-making point of view, what if we start aggregating it? So the first aggregation that we do is we say, well, we have these different LLMs and different prompts. Let's look at a uniform generative AI evaluator, which is one LLM and one prompt approach. And we contrast that with the human non-experts. And basically what we're trying to see is to what extent is the generative AI aligned with the choices of the human experts. We have two sets of measures. We have two sets of measures. One is in terms of correlations, and we see that the correlation is around 0.4, 0.5. And then the second set of measures is within a given industry. So the business models were grouped by industry. Do experts and AI pick the same top choice and the same bottom choice, right? So in some scenarios, it's not necessarily that you want to be on average the same, but you want to say, okay, do we pick the same winner or do we eliminate the same loser, right? So we're seeing that at least when we aggregate these, we're getting more sensible predictions than if we just look at them individually. And then we do two more steps. We say, okay, we don't just aggregate, but also we mix and scale. So rather than just one AI or one LLM, we look at multiple LLMs. And in the last comparison, we say, well, what happens if we combine all the evaluations? So many LLMs, many prompts, and so on and so forth. And basically what you see happening is the more you scale and more diversity you introduce, the more the choices of the generative AI evaluator align with those of the human expert. Then we sort of go to the other sample where the idea is, well, does this replicate or does this generalize to a setting with actual business models? So the generative AI approach is the same, 6 LLMs, same 10 roles, same 2 prompts. We start with 60 business models, which gets you close to 36,000 evaluations. The human experts in this case were historical evaluation of human judges who scored the business models, and that yielded 1 score per business models once we aggregate those, and that then forms a baseline. And what we see is the findings generalize quite well in 2 ways. First is we again observe that if you just look at one pairwise evaluation, they can be quite inconsistent. So the limitations that we noticed in the initial sample, we also find here. But once you do the aggregations in terms of more LLMs, more prompts, and scaling, what you find is that the correlation tends to go up from 0.5 to 0.7. And also the top and bottom choices within a group align quite well. So I started off by making the pitch. Well, maybe if strategic decisions are about commitment and irreversibility, prediction is important. What we're exploring here is the role of generative AI in providing those predictions. And what we find, if you just look at the individual pairwise evaluation, the properties are not necessarily that impressive because of this inconsistency. But if you apply this wisdom of model crowds approach, the predictions tend to sort of correlate or tend more towards those of human experts. Okay, so that is the first paper that I want to discuss. The second is ongoing work with 2 co-authors. And basically here, the strategic decision that we investigate is that of an M&A. So the evaluation of M&A at the announcement stage. So if you pick 2 companies that claim or that announce that they want to or intend to acquire or merge, can we sort of say whether this deal is value creating or value destroying? And the approach we take is thinking about LLMs, not just in terms of pure prediction, as we did in the previous study, but thinking in terms of can we make these systems more agentic, where agency is in terms of can we make them think and plan and act. So there's some configurations that you can use, some more information that you can make available is that they slowly start mimicking, not just in terms of predictive power, but also how humans would analyze and interpret and reason about some of these deals. Now, what we look at is 109 actual M&A deals or announcements. And it's quite likely that some of these deals are in the training set of these models. So what we had to do is anonymize the announcements before asking the generative AI their opinion in terms of, do you think this deal is going to be value creating or value destroying? The specific measure that we ask it to reflect on is cumulative abnormal returns of the combination, so acquirer and target combined, over a 7-day period. Because then we can actually match it or correlate it with the actual stock market returns and see to what extent generative AI can distinguish between M&As that are value creating versus those that are value destroying. So here are the setups of the different generative AI evaluators. So 1 and 2 capture those that we used in the previous study. So 1 is a basic prompt. You give the information, you ask, hey, can you give me your prediction? Evaluator 2 is a chain of thought prompt where you ask the same question, but in a series of steps. So first you say, okay, here's the announcement. Can you think about positive reasons? Can you think about negative reasons? And then in the last steps, so given all this information, can you make a final prediction? Now 3 and 4 start becoming more agentic. So in 3, you basically give initial instruction, but then you leave it to 2 LLMs to sort of figure out how to interact and deal with that information. So the LLMs that we're using is, one is a generator, which sort of takes the announcements and make a strategic analysis of the deal. Then the reflector reflects on that analysis and tells the generator or probes the generator, basically saying, why do you make this argument? Can you justify this? What about an alternative perspective? And they bounce back and forth that analysis a few times. And then after a few iterations, the generator makes a prediction based on that updated analysis. Then the last one is a multi-agent structure. So you have one manager who's responsible for making that probability statement, but it can rely on the input of sort of 2 employees. One is an M&A opponent. So it's tasked with always giving a positive perspective of any deal that is given. Or sort of that's a proponent. The opponent takes the opposite view, and it's always a negative perspective. So basically what the manager does, the manager LLM, it says, okay, here's a deal, give me reasons for and against, and it sort of goes back and forth and uses these different setup to get sort of a holistic view of the deal. And it's more agentic in the sense that there is like more thinking involved, and there's more autonomy in how to structure and how to resolve the problem. So, and yeah, we use similar, I think we use 3 LLMs here, but also in terms of aggregation, we do similar type of approaches. Here, what you see is the 4 conditions: base, chain of thought, reflective agent, and multi-agent. And each line is 3 different LLMs. So it's Gemini, is GPT, and I'll have to check the third one. It's probably Claude. Yeah, it's Claude. Now, the way to interpret this on the horizontal axis is how favorable the opinion of the generative AI is. So if you go more towards the plus or the 2 side, it's saying, okay, the generative AI thinks this is a good deal. If you go more towards the negative side, then the generative AI is saying, well, actually, this is not a good deal. And then on the vertical axis is the actual outcome, whether this deal was indeed positive or had CAR over that 7-day period that was positive versus negative. So an ideal evaluator would have like a screening function. So for negative values, it would have very low, and then a spike around 0, and then a high level for the positive values. A good evaluator would have a positive slope. A random evaluator would have a random or horizontal slope, right? So that means it cannot distinguish between those M&As that are actually good versus actually value destroying. Now, what you see is that base, chain of thought, and reflective agent are close to random in the horizontal line, so they cannot distinguish between them. And you might be able to see only like two lines instead of the three lines, and that is because the base and reflective agents are like almost exactly on top of each other. But also what you see is that there's a nice positive slope for the multi-agent. So that is showing some capability of distinguishing between value creating and value destroying deals. And we can sort of get sort of an economic understanding of the effect size. So what we do is we look at the predictions of that multi-agent evaluator. And there were 109 deals. So we separate the top half and the bottom half. And we say, let's look at the stock market returns of one portfolio versus the other. We see if the stock market portfolio of those that received the lowest scores went down by more than 1.2 billion over the course of these 7 days, whereas those in the top half went up by more than 500 million, right? So it's sort of it's not just that it can distinguish it by it, but there's a real economic consequences in terms of stock market reactions. So what we did here is like we're trying to add agency to these artificial evaluators. And we think that is relevant because when you're thinking about strategic decision making, it's not just making a decision once, but it's really thinking about, okay, planning, adapting, and reasoning through these approaches. So that's why we think agency, more agency with these evaluators might be helpful in understanding when these systems work well versus when they may not work so well. And yeah, the finding is that for a complex task, that is deals that have been announced, distinguishing between those that perform better versus less well, the multi-agent condition or the ones with highest agency level seems to be able to get some traction there. Now what I've been doing is, okay, can we use these systems to generate or like evaluate strategic decisions? I'm just mentioning here two papers that look at sort of the human side, assuming that generative AI is involved in making decisions. How will the decisions be perceived by employees who are ultimately responsible for implementing these strategies? So one is forthcoming in AMR, and the other is I'm working on with Raj. So I'm hoping that he will tell a bit more about it. But the point here is that even if we have these wonderful systems, there's still a human component to it. Is in once what are we gonna do with those implications or those recommendations from an artificial system? So let me just wrap up and saying, I'm very excited about generative AI as a technology, but also I think there's some clear benefits or opportunities that we as strategy scholars can use. And I hope that some of the studies that I outlined give some indication of where I think we can push more. But in general, I think there's a lot to be done, and we're only at the beginning. So I'm very, very excited about it. Thank you so much.
Thanks, Bart. I appreciate that. Let me see. I'm not seeing specific questions in here. I did have one. I think this gives me a ton of different ideas. I think the idea of triangulation we know is important in general, but your studies really sort of highlight that. And I'm curious what your thoughts are, going back to one of the things that Stephen said about maybe the accessibility of these tools. What are your thoughts on how we can enable scholars to be able to be competent in multiple tools and to even be able to combine them? Like what resources did you need to do that? And is it something that any scholar, any university could do, or are there specific limitations or constraints there that would need to be overcome?
Yeah, so I echo Stephen's point. I think this AI literacy is important for our students, but also and especially for us. So the work that I'm doing is, if you want repeated interaction with these LLMs, I think it's easiest to set up with APIs. And in the past, that required a bit of coding, but now, as you said, ChatGPT is so incredibly helpful. So I think it's just a little threshold, but it's actually fairly doable. So you can just call one LLM and then do a loop and say do it 10 times, and then each time to pick a different prompt. So that is not that complicated to code. I think it's more the initial hurdle, but ChatGPT itself should help you with the code. In terms of the cost, the second study that I was saying is with the artificial evaluators and where they're talking to each other, the cost used to be very high. So when they start talking to each other, they start throwing around messages, and each time you append like the history, or the history gets appended, so the messages get longer and longer and more tokens. And yeah, we ran up a bill around like £1,000, or like, so that was, then you really have to think about which experiment do you want to run, right? Because we chose 4 configurations, but you could easily think about 20. But the cost since the start of the study have come down enormously, right? So now I'm quite sure we can run most of the configurations for $50 or less, or for some even for $10. So I think there's always going to be a bit of barriers, but they're coming down rapidly and rapidly. And I think also these ideas of triangulation, I'm seeing now more and more, or there's like more and more research tools put in place where you sort of can select an LLM without you doing the actual coding. So uh, I'm optimistic about that. So I think the barriers are there, but they're coming down very rapidly.
Yeah, awesome. Thanks, Bart. There's also one additional question in the chat. I think I know how you're going to respond to this, but would you just speak a little bit to the comparison between the results and actual data in terms of the validity?
It's yeah, is this so in study 1, this was at the foreground, so we wanted to compare humans versus artificial intelligence. So if that's actual data, and then we did the business model competition. So in study 2, we're now at a stage that we also want to do with a human sample. So we're in the process of collecting that data, and yeah, we're trying some ways to get at that. So I think it's quite a common question, right? So and but it's not always straightforward, especially if you're thinking about strategic decisions, right? Because it's not always the case that there's a ground truth, and it's not always the case that there's an easy sample for human experts to get, right? The LLM you can code, you can do that, but the human aspect or your human perspective, even though I think it's very valuable, there's a bit more hurdles to get to them from time to time.
Yeah, I was in my own work, I've found even finding ground truth that's not fuzzy can be difficult. So
Yeah.
I think that's kind of an open question as well as we move forward and use these technologies. Thanks again so much, Bart. I appreciate it. We'll turn the time over to Raj now to conclude with this portion of the session, and after him, we'll hop into those breakouts.
Thank you, Joseph. Thanks for organizing this and inviting me. Can you guys see the slides? Thank you. So thanks again. So my name is Raj Chaudhary. I'm at the Harvard Business School. And what I thought I'll do is both provide an overview of a few of my own studies. And those studies include both Gen AI studies that I'm working on right now, but also going back to the studies using supervised and unsupervised machine learning methods, because I think those methods are also extremely useful. And I would argue that our maturity life cycle as scholars in using those methods is still developing. So there's still many people on the learning curve, and we should not forget how to use the supervised and unsupervised machine learning models as we are learning how to use Gen AI. So I guess the first study that I'll talk about was published in 2019. I believe this was one of the first studies in strategy that use both supervised and unsupervised machine learning. And this is a pure methods paper. So we had no hypothesis. And the motivation for this study was that now we are in this world of multi-dimensional data. So we have text, we have video, we have audio. Could we use machine learning methods to sort of navigate this multi-dimensional data sources? And the data set that we sort of use in this SMJ paper was the set of CEO videos that my colleagues at the Harvard Business School had curated for years. So for each CEO, we had about an hour of unstructured interview data, and then the question, purely as a methods question, was can we use multiple machine learning methods to get to some nuance of CEO communication style. So, of course, none of us on this paper were CEO scholars or upper echelon scholars. I studied the future of work, but this was just as an exposition of saying, since we have access to this data set, can we use multiple machine learning methods to learn something about communication style? So what we did is, of course, we used many of the methods that are now fairly commonly used. Uh, so we used topic modeling, which I think now is fairly, and we learned a lot from a paper uh, that Kayvan had written prior to us in SMJ on topic modeling, which I think is one of the early papers on topic modeling and strategy. But topic modeling, for folks who haven't used it, just gives you a sense of the topics that sort of been used to generate documents. And so it sort of back engineers the topics that are sort of most likely to have been uh, uh, used to generate any document in front of you. And then we used, I think, sentiment analysis, which is also widely used now. The topic modeling and the sentiment analysis was using the textual part of the transcript, because for each CEO interview, we had the transcript. But then we went one step beyond the text, and we said, now we have frame by frame the CEO facial emotions. And we used a supervised machine learning facial emotion recognition tool, which was being offered by Microsoft at that point. But we had to codify all the frames of all the videos and run each frame through this tool to generate a sense of whether the CEO was smiling, whether the CEO was looking serious, whether they were angry. And it was really interesting because some CEOs said very grim things with a smiling face. Some CEOs said some very happy things with a face that looked pretty angry. So it essentially told us in a very inductive way that our textual communication is often not correlated with the facial emotions that we're displaying. So we used that multiple sources of data, the topics, the sentiment, and the facial recognition, to just come up with some classifications, categories of CEO communication styles. And this was, that's it, that's the paper. And why those styles? Because those are the styles that emerged through a sort of conjoint analysis, and we named it anger, contempt, disguise, fear. Other researchers could have named it something else. And then purely because the reviewers kept pushing us, we did some analysis of saying what style correlates with what CEO decision outcomes. But we didn't want to do that, to be completely honest. We just wanted to show how to use these multiple machine learning methods. So topic modeling, of course, is unsupervised, while the facial recognition tool was supervised. So that was the paper. And I feel these methods are being used, but we are all on different learning curves. And I thought I'll do a quick recap. So this was the factor analysis that we ran to come up with these 5 or 6 styles. Then the next paper that we wrote was published, I believe, in 2020. This was with my former doctoral student, Ryan Allen. And here we essentially made a broader point. The broader point we made was that supervised machine learning methods can have a real, can add a lot of value to strategy research in the following way, that it can help us detect patterns in the data that have gone unnoticed. So this is, I think, going back to this point that, in strategy research now, we have accepted the multiplicity of of research approaches. So while hypodeduction and hypothesis testing, of course, remains a very important approach, but we have now accepted that research can also be inductive or even abductive, where you're explaining a pattern that you have generated. So the second paper was just making a point that supervised machine learning methods can be used in the spirit of induction, trying to find patterns that have gone unnoticed. And here again, this is a purely methods paper. We took a data set that I already had, which had employee data, and the outcome variable we chose was attrition. What explains attrition patterns? And what we find, to cut a long story short, was that if you used a naive econometric model, you would come up with a certain correlation between the performance during training and the probability of attrition. And that is something that might be predicted by prior theory. But there was an interesting nonlinear relationship that machine learning was able to uncover. And the nonlinear relationship was this pattern between training performance and the probability of attrition. Flipped sign, if you looked at the period of the first 6 months of the employee's tenure in the firm, and then the period after 6 months. And we had no theory in human capital literature or employee turnover literature saying that you need to think about attrition early in the career and later in the career. So this is purely an inductive pattern. And of course, if we tried all iterations of nonlinear specifications, we would have found it ourselves. But that's the elegance of machine learning methods, that it can run multiple iterations of the specification and come up with these patterns. So that's the pattern that we identified. And I'll essentially call out two things here. So given that this was a methods paper, table 1 in the paper, and this might be especially helpful for doctoral students, gives a step-by-step approach of how to approach inductive analysis using supervised machine learning. So you have to, of course, select the data, you have to select the algorithm, you have to set the regularization and other hyperparameters, you have to partition data for training, validation, and testing, and then you have to pre-process the data, take out the stop words and whatnot, and then you have to try to fit the model using each of these algorithms, and then you have to try to evaluate the predictive performance. So it gives a step-by-step approach if you are learning these methods and you're new to these methods. And by the way, we also, in the SMJ paper, we have a link to our code, and anyone can download the code and use that code for their own projects. But I think, and then we have some advice on selecting the right algorithm, because we used multiple algorithms in this paper, starting with decision trees to a random forest model to a neural net, a k-nearest neighbors model. But let me spend a minute on the discussion we were having earlier in today's session about robustness and triangulation, because I think the spirit of that discussion is something we should all take very, very seriously. So the way I think I would urge everyone who cares about these methods and are using these methods and are reviewing these papers is to demand the same level of scrutiny and robustness when these methods are being used as you would demand if some econometric regression method was being used. So the one way to do that is to demand for very transparent reporting of tuning. So what are the hyperparameters? And I'll come to Gen AI, and we should demand the same level of scrutiny and reporting on different Gen AI parameters that are being used in the paper. The other thing that reviewers and editors should demand is to show that the same pattern, the pattern that I described earlier, the nonlinear relationship between employee tenure and how employee tenure affects the relationship between training, performance, and attrition, you have to demand as a reviewer that that pattern is robust to using multiple algorithms. So if you found a pattern using just decision trees, but that pattern does not show up using random forest or neural net, that should be reported. And that's cause for concern. because we don't want this equivalent of p hacking while using machine learning methods, where you find some pattern using one algorithm or one set of hyperparameters, and those patterns go away when you use a different algorithm or a different set of hyperparameters. And you have to justify why you're using a certain scale of hyperparameters. You have to justify why that's efficient and why that minimizes the loss function in this case. Uh, so, and that's what we did here, where we showed the loss evaluation using 4 different algorithms. And this is more credible than if we had just used decision trees or just had used neural net. And then we are using the same amount of robustness and care in reporting the predictive performance, what is the ROC curve? Or when we're reporting these partial dependence plots, we have to show it using these multiple algorithms. So I think, that's what I thought I'll add, that, if you don't see this when you're reviewing a paper, you need to ask the questions, especially with unsupervised and supervised machine learning. What are the hyperparameters? Where is the code? Is this robust to using multiple algorithms? And the same thing we used for interpreting the models. So as you can see, the logit model here does not show the nonlinear pattern. The decision tree shows it. This is the yellow band here. And the random forest shows it very clearly as well. In the neural net, it gets more diffused. But at least it's very visible. It's very clear. It's in your, it's completely transparent. And then a reviewer or an editor can make a judgment about whether this pattern is robust. And then in my, I don't know how much time I have left. Let me move to my the papers on GenAI. So I guess GenAI is being used, GenAI tools are being used quite extensively now in strategy. And there are papers being written about how GenAI can support conversational guidance for customers, support agents, for entrepreneurs. This is the paper that Rem Koning et al. Have. For task augmentation for consultants. This is the series of experiments that Fabricio and Karim Lakhani and others are running with the consulting firm. So the paper that I'm working on with Bart and Miros is trying to think about the role of Gen AI in the realm of CEO communication. And why CEO communication? Because CEO communication is, of course, a topic that strategy scholars have studied quite a lot. And if you read the paper published by Bandier et al., CEOs spend a lot of time in just communicating with internal and external stakeholders. And a similar finding was reported back in the Michael Porter and Nitin Noria article in the Harvard Business Review. So, and CEOs, if you speak to them, they would like to get more time back to focus on decision making in the spirit that Bart was demonstrating. So they would like, if possible, if Gen AI could automate at least part of their communication, not all of it. So the paper that we are working on, that's under review right now, is a paper where we set an experiment with an actual real CEO. And his name is Wade Foster. And so we ran an experiment where we call the test the Wade test. It's a variant of the Turing test. So while the Turing test is trying to identify whether respondents can distinguish between a generic machine and a generic human, in this case, they're trying to distinguish whether the communication came from the machine, the Gen AI algorithm, or from a specific human. So that's Wade. So they're asking questions in this setting, and the answer has either come from the human CEO or this bot CEO, the Wade bot, and they're trying to identify the source correctly. And what we find in this study is that, now, before I get there, if you think about the communication, this is what we had to do with the Gen AI algorithm here. There are 2 parts to how we communicate, and we used textual communication, but the same principle applies to other forms of communication. There is the content of our communication, and there is the tone or the style of the communication. So the LLM in this case has to not only get the correct answer, which is the right content, but has to get the style exactly like Wade would answer questions. And the example I use when I teach is that, we all sign off emails differently. So some would write warm regards. Some would say best. Some would say cheers. So we need to know, how does Wade write answers? So our challenge in this experiment was to create an LLM engine that could impersonate both the content and the style of Wade Foster. So you can read the paper for the details, but what we did was we created a two-step process. In the first step, we took everything that Wade Foster had written in the firm in documents, in emails or Slack documents. And then we had a mapping from his communication style to what generic English is as written by managers. So we took every paragraph of Wade, we fed it into an LLM, and then, so this was actually done by the company. And they said the prompt was rewrite this paragraph in a way that a generic English speaking manager would write. So that gives you a mapping from Wade's way of writing to a generic way of writing. And then we flipped that to get a mapping from generic way of writing to Wade's way of writing. So then in the experiment, once we had the questions that employees would like to ask Wade, we then got in the first step, the correct answer, which was based on a retrieval augmented generation model sitting on top of the LLM, where we fed all company documents. That gives us an answer for the question. And then we had to pass that answer through this rephraser to phrase it in the way that Wade would phrase it. And so this is the rephraser, and I don't have time to go through the details, but you can read it in the paper. And then in the experiment, what we find, you might find this interesting, that the Wade bot actually passed the Turing test quite successfully. But that's only part of the story. There's an entire set of results on strong algorithm aversion that we can detect in this study. And if you're interested, you can find the paper, I believe, on SSRN, the latest draft. But since today's session is about methods, this is what we did with the Gen AI. But then as an AE now, what I'm observing is, and I think Bart's presentation alluded to this, that now Gen AI is being used as an agent in many strategy studies. In this case, in the Wade test, it's the CEO bot, the Wade bot, that's acting as an agent of communication. But these Gen AI agents are being used in many, many ways across studies in strategy. So this process has been described as silicon sampling, that instead of having human agents answer questions that we have used for decades in survey-based research, now we are creating these bots to satisfy different research purposes. You can ask bots to answer a survey. You can ask bots to come up with positives or negatives of a decision, like Bart mentioned in his ongoing study. So I would encourage folks to read up this paper that I'm showing right now, which talks about random silicon sampling. And this paper talks about both the opportunities, but also the challenges of this approach. And I'll briefly go through some challenges. But before that, there's also a very nice paper, not mine, which it's called the imitation game paper. So imitation game is, of course, the Turing test. So what they did is they used different Gen AI models to create agents, and they essentially had these agents perform 204 different tasks. So this is a paper written by 450 authors. So it's a very, very, very big project. But this is the BAG paper, as it's being called. And so this paper is a meta-analysis of what Gen AI is being able to do across tasks from linguistics, from biology, from physics, from software development, from social sciences, and so on. Now, in my final few minutes, I'm going to mention a few things that, again, on robustness and what we should be very careful. So, of course, the first thing, and there are many, 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 I won't get to all of them. Let me mention three. The one is the LLM data that's been used to create these agents and the LLM data that's being used by all of the Gen AI tools that I've looked at, including, ChatGPT and Llama and Claude and everyone, they are very biased towards some audiences, especially Western audiences. And there's a certain age group that is much better represented in that data. So if you are an emerging market scholar and you are trying to create an agent that would simulate a consumer in Nigeria or in Bangladesh, the Gen AI agent may not be a very good representation of that. So you need to be very careful about the LLM training set, data bias. Then there is a second set of biases that has been shown in a paper by Jones and Steinhardt, Steinhardt. It's a 2022 paper. And they talk about two cognitive biases of these agents. These biases they call framing and anchoring. So the anchoring bias is very interesting, that the agent gets anchored to their initial response and often moves very, very little from their initial anchored position. The framing bias is very interesting too. And this is, I think, the nuance of prompt engineering. If you ask the same question in a slightly different frame, then the response might be very different. So, what this means is that as reviewers, as editors of these papers, we need to ask for the same question to be asked in multiple ways. We need to ask for transparency by multiple algorithms. So we cannot just, if you see a paper that's just use ChatGPT, then the immediate thing is to say, go and ask other different algorithms on the Gen AI spectrum. And then if it's using the same question, just like in survey-based data, we used different questions to get to the same underlying construct. We need to see the validation of patterns using different prompts that all suggest the same thing. The other one is there's a very nice paper that I reviewed recently. It's Hagendorf, and I should mention this. I reviewed it, so please ignore that part of my comment. It's Hagendorf 2024. And they essentially talked about how these agents can be easily programmed to be exhibiting Machiavellism. So I think there is a very, very interesting opportunity here to take these agents and give them a Machiavellist twist and get a response that would satisfy the purposes of the researchers. So I think framing, anchoring, data biases, and the intention of these researchers in terms of what they're trying to achieve through these agents, those are the 5 biases that I'll mention. But I'm sure I'm missing things and others can jump in. So that's what I had, Joseph. I'll stop sharing my slides.
Thanks so much, Raj. I don't see specific questions in the chat yet. If you have some questions, please go ahead and post those now. I'll go ahead and ask mine. I've got questions on all of them. But one of the comments that you made, Raj, I'm wondering if you could speak a little bit more to. I completely agree the triangulation and being able to validate, using multiple algorithms that you're identifying similar patterns. I wonder a little bit about how consistently we should expect some of the patterns to map across different algorithms, though, particularly thinking about different classes of algorithms. Like you have the tree-based random forests, decision trees, where you might expect those to converge a little bit more. SVMs, sort of a different animal, right? So I guess could you speak a little bit more to what would we be trying to demonstrate? Would it be perfect consistency, which I don't think we're ever going to find, or how robust should we expect some of these to be across models and algorithms?
Yeah, no, I think that's a good question. And in the SMJ paper, the paper with Ryan Allen, we provide some guidance of choosing algorithms based on considerations like how much data you have. So you need certain data sets. The size needs to be to certain levels to use some of these algorithms. But my recommendation is, or my suggestion rather, is that I think more is better here. We need to be. And if some patterns are not consistent, let that be reported transparently as well. Because I think in the spirit of induction, we're not testing hypothesis here. We're just reporting what we're finding. So there is no sort of stars or statistical significance here to achieve. And I think one of the ways that we can get around a lot of these problems that were being discussed earlier in the seminar today is just by embracing induction. That we do not need to find robust, consistent patterns all the time. And multiple studies. So after a bunch of inductive studies, then there could be a hypodeductive study, right? So that's my personal philosophy.
Yeah, I think that's a great approach. Thanks, Raj. There's also a request if you would, Raj, would you mind posting the link to that article, the randoms? I think the reference was to the random silicon sampling
Sure,
paper.
absolutely, yes.
You would do that in the chat, that would be great. All right, excellent. Well, thanks so much again to our three panelists. I think they did a great job of demonstrating both the differences between what we've seen in the past with supervised machine learning and what these generative technologies now are allowing us to do, answer different questions, analyze different sorts of things, creating these agents and these bots are all, I think, really intriguing new avenues for our research that go a little bit away from the traditional econometric analysis that we might be used to. So